Hello friends, welcome to Shiksharthi. In this video, we shall be discussing the basics and the concepts of coordinate geometry. So let's start. So the very first thing that we need to understand when we talk about coordinate geometry is the word coordinate. The word co means two or more things happening at the same time. And then we are talking about geometry. That means the topics which are very closely connected to a topic like coordinate geometry is geometry in the very first place. And when we are talking about geometry, then we can refer to trigonometry as well. And even before that, something which is without which coordinate geometry cannot be discussed at all is the equation of lines, the linear equation of lines. So when we talk about a line, basically we're talking about linear only because a line has, or the word linear has a line in it. Okay, so now when we are talking about coordinate geometry, we can talk about, as we talked about, it means two or more ordinals happening at the same time. So two or more verticals. Do not take verticals as I'm speaking, because vertical does not mean necessarily vertical only. What I'm referring to here is, if I draw an XY plane, so let us say there is an XY plane that I have drawn here. Now here we are talking about the Cartesian plane. So as discussed in my other videos also, when we refer to a word like Cartesian plane, we are basically talking about real XY plane. So a plane on which real numbers are represented is when we talk about the Cartesian plane. Right? Okay. Now when we are talking about the Cartesian plane, and now we are talking about coordinate geometry, and we know that linear equations or the line concept is very important. And why do we say that lines are very important? Because the Cartesian plane is drawn with the help of two straight lines. Now when I say this is a straight line, so I will have to have an arrow. Arrow signifies what? It is unlimited. The line extends from one side of the infinity, which is the negative side of the infinity, to the other side of the infinity, which is the positive side of the infinity. And in between we have a term like origin. Origin is 0, 0. We have a term like origin in between, which signifies what? A non-negative or a non-positive situation or a point. Now this can be labeled as the positive side of x-axis, and the other side, this can be labeled as the negative side of x-axis. This is the negative side of y-axis, and this is the positive side of y-axis. This is talking about the line concept that we use. And once we are using the line concept, the next point that arises here is writing down the equation of a line and how to represent, how can I represent a line with the help of points, because a line is formed of infinite number of points lying on the line. So if I talk about x-axis, this is nothing but my x-axis and this is nothing but my y-axis. There is another way of representing this is the x-axis. The equation can be written as y is equal to 0. And for the y-axis, the equation can be written as x is equal to 0. This is the first and the foremost thing that you need to understand. So let's say this was the first concept. Why do we associate lines with coordinate geometry and so on? Now the next is, we were talking about coordinates. Coordinate means we are basically talking about two. Now what are we talking about? We are basically talking about two planes. One is the x plane, the x axis, so two dimensions. We are having two dimensions. One dimension is the x axis and the other dimension is the y axis. So let us say if I take a point here. So this point, let me say that if I take it as point A. Okay, now if I have taken this as point A, now I know that this is lying in the first quadrant. This is known as the first quadrant, and the quadrants, they start from here, and the order of going is, this is anti-clockwise. You go anti-clockwise, you start from this quadrant and you move on to the other quadrants. So this is a very important noting that you need to do. This is how you start from the first quadrant and end on the first quadrant, or maybe you end on the fourth quadrant. But this is the direction that you take. That is the direction that you are taking in order to ascertain the quadrants, and the points lying inside the quadrants will be basically decided by the anti-clockwise direction from the positive side of x-axis. So you will see that all these angles, for example, this becomes theta. If this angle is theta in the first quadrant, now here, if I say this is theta, which in any case is 90 degrees here, so this becomes pi minus theta. Right? These are vertically opposite angles. This also becomes theta, right? So which here I can say it is minus theta, and then I can take it to a next level. So you can associate trigonometry also along with this. As I discussed earlier, also trigonometry, geometry, coordinate geometry, and lines. That is equation, a linear equation with two variables or a single variable, is something which closely knits this topic. Okay. So now when I talk about this, so this is the second concept that we discussed. So in the first quadrant, if I take this point A, I know that the x coordinate is also positive and the y coordinate is also positive. Now the x coordinate is known as abscissa. The point, the specific term. So this is a mathematical jargon when you start giving them technical names. So the technical name that is given to the x coordinate is nothing but the abscissa, and the technical name given to the y coordinate is known as the ordinate. So abscissa and the ordinate, these are technical words used while we talk about the x coordinate, which is abscissa, and the y coordinate, which is known as the ordinate. Okay, now if I take this point in the second quadrant, so let us say if I take the same point, so let me say that this was A1, this is A2, and if I take this as symmetric means this distance. So we are talking about the distance of this point from the y-axis is the same of the point A2 from the y-axis. In that case, I can say that this is minus x comma plus y. Now if I take the same point down below, and let us say now I am representing this point by A3, and if I say, and then I take it to the final quadrant, which is this, which is the fourth quadrant. So all of these are right angles. I hope you would understand why all of these are right angles. So this becomes my second quadrant, this becomes my third quadrant, and this becomes my fourth quadrant. Okay, so now the same point when brought forth downwards, as we were talking about, so do I have a line now? So if I talk about the line which is formed because of the points A2 and A3, can I say this line will be parallel to y-axis, and the line A1 and A4, this will also be parallel to y-axis. At the same time, the line A1, A2 will be parallel to x-axis, and the same line will be parallel to the line which is A3, A4. Now the resultant figure that is formed here, we'll talk about this figure as well in few minutes. So now if I have to ascertain the point, so here the point, I know that the x coordinate and the y coordinate, both of them are negative, and you will be able to say that this is minus x only when you specify that these are equal, so are these. And here you will say that the x coordinate is positive, which is abscissa is positive, and the ordinate is negative. This is talking about how to represent a particular point in which quadrant. So which you can fairly understand now. This is plus plus when we talk about x comma y, this is minus plus, this is minus comma minus, and this is plus comma minus when we talk about representing a point on the Cartesian plane, because as of now we are talking about the Cartesian plane only. We are not talking about the Argand plane. What is an Argand plane? Argand plane is a plane on which non-real numbers, which are essentially real, non-real numbers which are essentially imaginary numbers, which may be represented on an Argand plane. Oh, so this was talking about the representation of x comma y. Now, the next discussion which arises from the discussion which has already taken place, if I take a point x comma y, which is, let's say, the point A1. So the distance of this point, so when I talk about the distance of this point, I'm basically referring to the perpendicular distance. So the distance of this point from the y-axis, and this is nothing but the x-axis. So the distance of this point from the y-axis is this. Now what is this? This is the abscissa part. So the abscissa part is how much? This is x. So can I say, if I project this point here, so here, what are the coordinates? The abscissa would be x and the y, which is ordinate, is 0. Now this point becomes 0, 0. What is this point? So here on the y-axis, the abscissa will always be 0. And on the x-axis, the ordinate will always be 0. So you get a resultant figure. Which figure is this? It can be called either as a square or as a rectangle. And the same you could have said here. Why do we call it as a square or a rectangle? We call it as a square or a rectangle is because of the fact that the vertex angles are 90 degrees. All the 4 vertex angles are interior angles are 90 degrees. Okay. So it is better to call it a rectangle as of now. When does it become a square? When y is equal to x. So that means, when will y become equal to x? Maybe when I draw a line, which is a line y is equal to x. Okay, coming back to that later. So can I say now this distance? So let us say now this is A1. Let this be as B. This is 0. And let's say this is D. Let's put it as C instead of a Z. 0, which is O. And let's take this point as A. So now the quadrilateral which has been formed here is formed because of the points, vertex points A, B, C, D. Now what can be said further? We can say that this quadrilateral which has been formed is either a rectangle or a square, which we have already reasoned it out. Now can I say here that AD will be equal to BC, which is equal to X, which is the abscissa part? And at the same time, can I say AB is equal to CD, which is equal to y, which is nothing but the ordinate part? Yes, I can say this. Once you have said this, that means we are talking about the length. So this becomes a line segment now. When you're talking about the length, this becomes the line segment AD and line segment AB. Can I find out the line segment AC? Yes. And how? You just need to draw this. So now you can apply Pythagoras theorem. So Pythagoras theorem says AC is equal to under root of AB square plus what? Now AB square plus BC square, which is just like saying under root of x square plus y square. So from here you learn what? You use the distance formula which arises out of Pythagoras theorem, and which says that the distance of a point x comma y from the origin is nothing but under root of x square plus y square. Now when I take this discussion further, so if I want to calculate the distance between any 2 points, this can also be understood as there are 2 points A and C, and then when you are finding out the distance between 2 points such that one of the point is 0, 0. So this I could have written it as, this is nothing but x minus 0 plus y minus 0 under root. And if this point would not have been the origin, in that case I could have written this thing as x minus x1 whole square plus y minus y1 whole square, and then I take the under root of this. So what I am trying to say here is, this is AC. If this would not have been the origin, let us say I extend this point further and I say that now this point is E, and now I want to find out the distance between the point AE. So what I am expected to do here is, I am just extending this entire discussion. So in that case, can I find out the coordinates of y of f? Yes, the coordinates of f are, let's say this is x comma y1 Now this y1 is this has arisen because of the distance here. And can I find out the coordinates of E? I can. So on the x-axis, now you have a line which is parallel to x-axis. So on the x-axis there is no scope for, the y part. But on the x-axis, the x part remains the same. On the y-axis, the y component remains the same. So when I'm drawing a line which is parallel to x-axis, and I know that the coordinate of f, the abscissa of f was x. So in that case, can I say the abscissa for E would be different? Yes. And the abscissa for E would be, let's say, x1. But on this line, when I'm talking about a different abscissa, then the ordinate remains the same. Right, now you can use the Pythagoras theorem and you can say what? You're saying nothing but this only. So if I were to find out the distance AE, it is nothing but x minus x dash x1 whole square plus y minus y1 whole square. Wherein if I want to know what is the distance AF, so if I want to find out the distance AF here, we can find out the distance AF as well. Now AF, I know that the abscissa part remains the same. It is only the ordinate part which changes. So the distance AF will be y minus y1, right? And if I want to find out the distance EF, which is nothing but the length of the line segment EF, on this I can say the ordinate part remains the same. So we can find out the distance for the abscissa part, and the distance here is x minus x1. So once you know this distance and you know this distance and you know Pythagoras, so you know that from here AE will be nothing but under root of AF square plus EF square. Now as you have been advised earlier also, I know that some of you would know these formulas, but then if you are able to find out the origin for the formulas, how are they given rise to, you delve into the topic, and once you delve into the topic, it makes you prove the theorems, and if you are able to prove the theorems, it becomes easier for you to remember the theorems in the very first place, because you need not mug them up. You have already proved it, you know how to do it. Second, when it comes to the application of the theorem in various questions that would be given to you, it becomes relatively easier for you, because first, there is no need for you to remember the theorem or mug up the theorem because it is on your finger ends. Second, you can apply it because you know you have a fair enough idea of plotting, and then with the help of plotting, coming down to some inferences or conclusions. If you feel that this video was really knowledgeable, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. If you want us to do some videos on specific topics, do not hesitate and put it in the comment section so that we can do it for you. Thank you so much. Until next we meet, goodbye.